size of Manhattan is hurtling towards Earth from the dark depths of space. It travels at a speed of 30 kilometers per second, which is roughly 150 times faster than a commercial jet airline. And it's on a deadly collision course with Earth. What should we do? What if we try to blow the asteroid up using our advanced weapons? Could a nuclear bomb do the trick? And what happens when we detonate a nuclear bomb in space? This is Mystify, and this is what would happen if you set off a nuclear bomb in space. Before we continue in this video, make sure to subscribe to this channel and smash the bell button so that you'll be the first to know when we publish our next brain-boosting video. Right, back to the life-threatening rock speeding towards us. This piece of frozen rock is the same size and travels at the same speed as the one that killed the dinosaurs 65 million years ago. That asteroid left a crater 180 kilometers in diameter and 20 kilometers deep. Immeasurable earthquakes rocked the planet, and 50-meter-high tsunamis washed over the Americas, killing everything in their way. Fire rained down from the skies as the plume rose, and after, the deadliest winter followed as the dust from the impact covered the sky. 75% of Earth died following the impact. That little piece of historical science is enough to convince us to deploy our most powerful weapons to defend ourselves: nuclear weapons. But would they actually work in space? And what would happen if we detonated them beyond Earth's atmosphere? Have we ever tested them in space to see what would happen? The short answer: yes. During the Cold War, the USA tested the effects of nuclear explosions in space, and the results of these will blow your mind. Excuse the pun. Before we look at what happened, we first need to understand why the USA would spend a ridiculous amount of taxpayers' money to conduct the largest nuclear test in space history. In 1958, an American space scientist from the University of Iowa announced something incredible about our planet that was not known at the time. He was the front man that led the scientific community to put research equipment on satellites and discovered what we know today as the Van Allen belts. The Van Allen radiation belt is zones of highly energetic charged particles trapped at high altitudes in the Earth's magnetic field. This belt is actually a vital part of Earth's defense against the continuous onslaught of the sun, protecting us from the dangerous particles ejected by the sun during solar flares. Van Allen made the discovery in May of 1958, and on July 9 of that same year, the US sent the first missile up to blow it up. It was literally a case of discovering something new and blowing it up to see what happens. So what could cause the US to act like a bored child home alone who just found a stash of cherry bombs? Well, this period was the peak of the Cold War, and the general belief regarding weapons development and testing was, if we don't do it, the Russians will. And in defense of the military commanders of the time, they were not aware that the Van Allen belt was vital in protecting life on Earth. Enter Starfish Prime, a top-secret project determined to study the effects of 5 nuclear explosions in outer space. Let's stop there for a second. To understand this concept, let's refer to those swinging metal balls you nervously stared at on your principal's desk so many times during your school career. That is actually called Newton's cradle. Now, the idea was that if you detonated a bomb in the Van Allen's belt, the force would run through the magnetic band of charged particles, just like the force within those metal balls, and slam down somewhere on Earth, thousands of miles away, like say in Moscow, for instance. Excitement grew before the first bomb went up on a missile called the Thor missile, about 31 kilometers southwest of the Johnson Atoll, a small group of islands in the Pacific. 27 smaller missiles were sent up alongside the main missile, carrying scientific instruments that would record and replay information following the detonation. The newspaper headlines before the explosion on the Hawaii Advertiser's read, "End blast tonight, maybe dazzling. Good view, likely." Hotels were hosting what they called rainbow bomb parties on rooftops and verandas. The residents on the islands of Hawaii were about to get a whole lot more than what they bargained for. The first bomb that was transported into space on board the Thor rocket was a 1.4 megaton bomb, 500 times more powerful than the bomb that was dropped in Hiroshima. It was detonated about 400 kilometers above the Earth's surface, and unlike those detonated close to Earth, there was no mushroom cloud or double flash. There was no sound, and the people on the ground didn't feel a shockwave. It was just a bright ball of plasma that changed colors. As predicted, the bomb produced brilliant auroras that were seen as far as New Zealand. Just like the natural auroras, or northern lights as most of us know them, the radiation particles created brilliant displays of blue and green following the initial blast. The blue light is formed when the charged particles react with nitrogen in the upper atmosphere, and the green light when they react with oxygen. That is why nuclear bombs detonated in the upper atmosphere or space were referred to as rainbow bombs at the time. However, what followed this brilliant display of light was less spectacular. When the bomb exploded, people on the islands of Hawaii, some 1,300 kilometers away from the explosion, experienced electrical blackouts and strange electrical malfunctions like garage doors opening and closing on their own, alarms going off, street lights malfunctioning, and disruptive effects on radio communications. It also damaged the first communication satellites of both the USA and England at the time. This was caused by the EMP of electromagnetic pulse caused by a nuclear explosion. Had this test been conducted above the usual test site in Nevada, the consequences would have been detrimental to both civilian and military electrical system all over the USA. It was reported that electrons from the explosion were still present in the Van Allen belt 5 years after the first explosion. These are valuable lessons we need to learn if we were to shoot down that killer asteroid with nuclear weapons. The explosions need to occur thousands of kilometers away from the Earth, because the excess radiation and electromagnetic effect will be detrimental to our array of satellites orbiting Earth, not to mention the danger the radiation holds for astronauts. In 1959, following the test in the upper atmosphere, the USA, UK and USSR signed the Limited Nuclear Test Ban Treaty, and since then, no more tests have been conducted in outer space. The USA and USSR agreeing on something and signing a ban together during the height of the Cold War should be an indication of how serious the effects could be of nuclear explosions in space close to Earth. Now that you know what happens if you detonate a nuclear weapon in space, do you think it's a good idea to use it as a defense against possible annihilation from an incoming asteroid or comet? What other methods do we have at our disposal to save ourselves from the same fate as the dinosaurs? Thanks so much for watching this video. We hope to see you next time on the Mystify.